It's no secret that I'm really hyped on partial pre-rendering. It's a feature I've been asking Vercel for I think 2 years now. A bit over a year and a half ago, I did a Twitter space that Dan Abramov showed up for and spent a lot of it explaining why this feature is important. The best I can TLDR it is that you should never have to block on a server for a user to see something from your app. If you go to a website, you shouldn't have to wait for a server to spin up just to send that first response. That first response, if at all possible, should come from a CDN, and then the rest of the content should come in from a server when it's done preparing. With the new app router model around server components, there is kind of this implicit expectation that React has to process and respond with the first byte. And the result was a better overall experience. When it came to the first load and navigation type behaviors, it actually felt a bit slower, especially if you were blocking on a cold start from a Lambda. It would take 3 seconds before you saw anything other than your browser's white loading page. That was unacceptable. And I pushed really hard for the React team, the Next team, and Vercel to address this because I thought it was important. I shouldn't have to block until the React server picks up for users to see something. And all I wanted was the ability to take that first response the server sends and cache that on a CDN and let the rest come in later. And that's exactly what they built with partial pre-rendering. I could sit here and talk all day about how hyped I am, but I'm going to let Lee talk a bit about what it is and how it works and let you guys see my genuine reaction as I see him break it down.
We're working on something in Next.js I want to show you an early look at, and it's called partial pre-rendering. It allows you to have the best parts of both static and dynamic rendering in the same page with
no new APIs.
I'm really happy they did this. People keep complaining about how much is changing in Next versions. I'm annoyed with that on 2 sides. One is that everything from the old Next versions works. It's been a while since they deprecated something. Same deal with React. You can use page router in Next 13 and you can use page router in Next 14. But also the new APIs are a lot and are scary to a lot of people. So I understand the frustration. That said, there's no new APIs here. There's nothing new to learn with Next 14. And I think it's important that we get excited about that because it's a nice change.
Let's take a look. If we go to partialprerendering.com, if I reload the page, you'll notice it's really fast. And that's because we have fast global ISR. So we have a fast initial static shell. And then the dynamic part is streamed in after the fact. So the recommended products, the information about when you can get this product, the customer reviews, all highlighted by this pink dot. And the best part is this is all programmatically defined how you want. So you get to control what the user experience is like. So in one request to the browser, you're able to immediately get back that fast static shell and then basically concatenate on the dynamic parts or stream in the dynamic parts after the fact without having to do any additional work.
Yeah, I'm going to stop here because there's some really cool stuff I want to highlight. Ricky from the React team highlighted the difference here, showing an example of a pretty common app behavior. You have your front end, this probably shouldn't say front end, I'd probably say like top nav here, you have an image, you have product name description, all these things. All of this content is static, but the number of things in your cart, that's dynamic and unique to the user. Delivery time is dynamic and unique to the user. Recommendations are dynamic and unique to the user. So being able to make all of these static parts static so they come back from a CDN instantly and stream in the rest after, that is incredibly powerful. That makes your apps feel so much faster. That said, it also means you're now experiencing pop-in. And I think Kent has some very reasonable pushback here around the importance of making sure we handle layout shifts. Like what if the cart, once the content comes in, is slightly taller than this was before? It's going to cause the whole page to shift, and that's a really bad experience. So there's 2 ways to solve this. One of the ways is going really deep on the suspense boundaries and fallbacks, making sure they're guaranteed to always be the right size. I think for something like the 0 items thing is going to be annoying. Ideally, all of the content that streams in is beneath or separate from the content that's static, so you don't have to worry about containers changing in size when content comes in. You can do it with good suspense fallbacks, but it's not a guarantee. One of the points that Guillermo tries to make here is that you control how much goes into the pre-render. So this is a primitive. You can say, hey, I want the whole page to pre-render. I want most of the page to pre-render. Or what I do a lot of the time, and I specify here, I have almost none of the page pre-render. I don't think actually I said that specifically here. Even if your loading state is a blank page, it means speeding up the load of resources like CSS and JS and fonts. So if you have a static shell and you wrap your whole page in a single suspense, so none of the content comes in, maybe you have a background color that you changed. Otherwise, the content's not there. But if you have a static HTML shell with empty content that has your CSS tag, your JS tag, and your font tags, the browser can start loading all of those while the server spins up and starts sending its response. You're still having a massive benefit here in terms of performance and also in terms of the perceived user experience, even if you're barely using the feature. That's the power of this feature. You have much more control over how these patterns work. you have this primitive where you can choose, do you want nothing to load in ahead of time? Do you want just a static shell to load in ahead of time? Or do you want everything to load in ahead of time? And you have that dynamic control now by using suspense as the boundary where things become dynamic. And while I agree that content flashing in sucks, and I call that out a few times here, I think we end up agreeing, maybe not in this thread, but in a couple other places, we ended up agreeing a lot where all of your content flashing in sucks. Like the number of websites that are going to have a sign-in button that becomes a user icon is going to go up from this change, not down. And I don't like that, but it's reality. This little, if you think of that as like the user sign-in button, and that's now being flashed in because it comes in 30 to 100 milliseconds later, that's not a great experience. And you as the developer have to make these decisions in order to have things feel good. But that's also why I like this feature. It's not telling you how to do this. It's giving you the pieces so you can do it the way you want to in the way that feels best for your application and your users. Enough about the thread. I want to watch the video actually demonstrating the feature.
Let's look at this demo and see how we're able to do this with no new APIs defined by your suspense boundaries. So I have the code running on the left in my editor. On the right, I'm just looking at a blank page right now. And what I'm going to do is I'm going to navigate to localhost 3000. And we're going to see the browser loading spinner spin and spin for a couple seconds. We're waiting for the slowest data fetch on the page to finish before we render all of the content. So it's kind of all or nothing. And I have these times defined by some constants in my application. So the reviews, for example, take 2 seconds. Now, the great thing about partial pre-rendering is that I have the flexibility of how I want to define this loading experience in my application. So for example, let's say that these reviews, the slowest part of our application, maybe instead of directly fetching these here with some delay, maybe we want to wrap these in suspense and we want to have a fallback for the loading skeleton to show. So let's take a look, going back to our blank page and then navigating to localhost 3000. It's a little bit faster. So we aren't waiting for that slowest data fetch in the tree now, which is the 2-second delay. And if I reload the page, it's even, it's pretty decent. It's a little bit better. But what if we could go even further? There's other places in our application where we had some asynchronous components that were fetching data, like in this header, where we're fetching the cart count from the cookies.
One thing he doesn't mention here that I think is important is that in this example, the fastest content is near the top and the slowest is near the bottom. So things pop in top to bottom. And as silly as this sounds, that is a much better user experience than top pops in, middle pops in, top right pops in, bottom pops in, cart gets updated. Like things changing up, down, left, and right in your app feels much worse than a linear top to bottom, more content gets loaded in. And as silly as that sounds, that you do feel the difference. And I think this example is both good because of that, but it's also important to call that behavior out. Back to it.
You know what? Let's put a suspense boundary on that. And then also over for looking at pricing, we also had the ability to add to your cart, which is reading from cookies. So we should put a suspense boundary around that. And then also some of these user specific details as well too. So I'm programmatically defining where I want the suspense boundaries using my code, defining fallbacks, and then the Next.js compiler can automatically create the static optimization here based on your code. So if I go back to about blank, now with all these changes, and I navigate forward to this new updated version, it's really fast. The first version that we get has the majority of the static shell because we made as much of this page static as possible. And then subsequent reloads, as you can see by the pink pulsating dots, those are the parts that are streamed in after the fact. Now, to go a little bit more in depth on this, I'm going to walk through the blog post that Sebastian and Malta wrote, which is fantastic. So we'll step through here and I'll just provide some commentary on some of them.
Love you, Lee. That's my job. Let's go grab that blog post. Building towards a new default rendering model for web applications. Look at partial pre-rendering with Next.14 on Vercel. And this year at NextConf, we discussed the developers and user experience challenges of globally delivering dynamic web applications. How can we fetch data without expensive waterfalls and also deliver content directly from the edge? The answer to all of these current challenges is partial pre-rendering. Partial pre-rendering combines ultra-quick static edge delivery with full dynamic capabilities, and we believe it has the potential to become the default rendering model for web applications, bringing together the best of static site generation and dynamic delivery. Yes, I've been asking for this for so long. Let the static parts be static. Let static be static is almost what I want to title this video because that's my goal here. Today, you can try an experimental preview of partial pre-rendering with Next.14 on Vercel, or visit our demo site for a first impression on partial pre-rendering. I am happy this is working now for the most part, because it did not work at all at NextConf. And if y'all want proof that I'm not just here to sit and shill every single detail of what Vercel does, I think they kind of bodged this launch. They talked about it a bunch at the conference, and it just didn't work at all. It was even like a joke amongst the Vercel employees I was talking with. And I get it, that's fine. It's just a little weird feeling to see a bunch of hype around a feature and then go home and open my laptop and it doesn't work. That said, it's mostly working now. There are still things that aren't, and they call it out. They've actually been pretty public in their pull requests and in their GitHub issues about how many things aren't working, including client navigation, which hopefully by the time this video is live will be fixed. But this feature took a lot of effort, both on the Next side and the Vercel side. And funny enough, it was working in Next.js and it was not working on Vercel at conference time. So yeah, love you guys. Make sure your things work before you announce them on a conference. It makes my life harder. Happy it's working now. Happy we can finally talk about this, because the win here is massive. I really like this diagram. I don't know if I would use edge delivery, because there is a performance win from a CDN versus an edge render. And I feel like it's not calling out enough on that here. It does a little bit with the does not block time to first byte on cold start, but meh, it's not a big enough call out. But yeah, traditional SSR does solve that. But then when we compare to ISR, which for those who aren't familiar is incremental static regeneration, the concept is the first time somebody goes to a page, it makes a cache of that, and then the next user hits that cached version of that page. That concept is great. ISR is why ping feels fast. When you navigate the ping site, it flies, because we incrementally statically generate the pages as you go to them the first time, and now that page is cached on the CDN as a very empty shell. It's usually just the loading spinner. Like if I go to ping, cool. So now when I load the page, you'll see it's just this empty loading state with the little loading spinner. That page is coming from a cache, from a CDN cache. So when I refresh, I'll show you, I am pressing Command-Shift-R right now. You get something back instantaneously, because that empty minimal page with the JavaScript bundle, with the CSS, with the fonts, with all of that is coming from a CDN, and you can get it instantly. And the result is that navigating ping feels lightning quick. Sure, you can have access to my camera. Really proud of the result with ping, but in order to do that, we have to do a lot of work on client. So when I open up the network tab on this page and I refresh, you'll see a lot of things have to happen before we start getting the rest of the content. So we load the dashboard HTML. This comes back in 56 milliseconds. 19 milliseconds sometimes. That's insane. So we get back page with content in 19 milliseconds. But then we have to load all of this JavaScript. And then that JavaScript can now start rendering and realize it needs data. It needs to know the rooms that this user has access to. This takes another 268 milliseconds. And that's after all the JavaScript has already been downloaded and run. This is with ISR. And the result is that a lot more stuff has to be done before you can actually get the content. So you get that cached CDN initial piece, then the client has to do a bunch of work, and then the rest of the content can come in. And that's what partial pre-rendering is designed to fix. The new model with PPR, it's not blocking the rest of stuff until after the client has run the JavaScript. Without PPR, using ISR or even traditional static site generation, once the dynamic behaviors need to come in, you need the client to do it itself. With this model, the server can send that cache response, and then it can fill the rest in after. If we compare that to the network tab on this page, we're going to see a huge difference here, where yes, we're still loading in all of this JavaScript, but most of the content comes from this here. We get that first response 77 milliseconds later, and then the rest all comes in as part of this response, because it's streamed in from that first request. That is the magic of this new model. You don't have to wait for the JavaScript to all run, parse, and then make an additional fetch request that then spins up the server again. Let's say it takes 1 second to get the recommended products. That 1 second starts with this model right when you start loading the page. With ISR, that 1 second starts after you load the page, the client parses its JavaScript, the client authenticates, and then the client makes a request. That adds a 300 millisecond to often sometimes in certain internet conditions, seconds long delay. And one of our favorite chatters mentioned in chat earlier, African Scam Call, mentioned that his internet is slow where he is, but partialprerendering.com loads everything together. So the dynamic parts load alongside with the CDN content. Really cool. Yeah. When you have slow internet or a slow device with a bunch of JavaScript in it, it's slow. And you feel the difference there. When your device is blocking when the server can start working, things are slower. There's no argument that your first server request should start computing the hard parts. But with partial pre-rendering, that now works alongside the CDN cache. Previously, there was kind of a an either or here, where you could cache the first response, but now to fill the rest of the page out, the client has to parse the JavaScript, figure out what it needs, and then request it from the server. With traditional SSR, you couldn't send anything from the CDN, but you could do all of this data fetching on the first request. The result was you had to block the user until that response was generated by the server. This is a best of both, where you can get the dynamic content as fast as the user requested it, but you can also give them something else earlier. I saw a chat message. I think I just clarified this point, but is this similar to just loading the data on the client? No, it's not, because for the data to load on the client, you have to request it from the client. In order to request it from the client, you have to load a bunch of JavaScript, make other requests, parse the JavaScript, render the page, and then realize what data you need. And that whole time, your server could be spinning up and generating the response. With this model, you don't have 2 round trips. The CDN is part of their edge network, so that same first call starts the server filling in the rest. And that one network call has everything coming in at once. With the old model, you had to wait until the client figured out what it needed before it could start requesting that stuff. It's so much better. It's not one request, wait for the client, then the real request. It's one request, give the client something, and then fill the rest in when it's done. Of course. And thank you for the question. It makes it easier for me to explain this to people who will be commenting on the video saying they don't get it anyway. So hopefully these additional details and pieces help people understand it better. Yeah, let's go through all these points. So fast edge delivery. I think CDN's a little faster, and calling that out is important, but they kind of call it out with the cold start, because even an edge has to spin up and start running JavaScript to get a response to the user. If you can give them the response before that happens, you're no longer blocking on that. Also, the dynamic delivery is really cool, being able to stream in content that takes longer, no extra round trips, fast access to core region databases and APIs. This is an interesting one, because are we going to go into the edge location versus edge infrastructure thing again? We're using edge for a lot of stuff at upload thing right now, because we want our pages to feel fast while using app router. But since our databases are in one region, we have chosen to limit which edge locations our code runs in to just that one region in US West. Because of that, we have very low cold starts, we have edge SSR, but we also have really fast data. The catch is, now when you're going to our homepage, if you're in a different region, you're not going to hit a CDN cache in your region. You're going to be fetching from this cold started edge code from US West. That's a huge change, that now we can edge route the CDN part that doesn't need to talk to a server, but our server part can still be close to our database and stream in when it's ready. This is such a cool dynamic that gives us a ton of power. The other thing they call it here is that they didn't add a new API here. This is one battle-tested programming model. Rendering happens in a single React render tree. Static optimization is on by default and covers all components until the app accesses incoming request information like headers or cookies. So if you have a component that checks your cookies before it renders, and that component's not under a suspense, that route won't be static. It will be dynamic. But if you have all of the things that check headers and cookies and all of that underneath suspense boundaries, they can static render the outside of it. So if you don't want to change anything about how you're building, you just want some of the slightly better performance characteristics, wrap your whole app in a suspense. Now you'll get the static shell, you'll get all of the CSS, JS, and embeds and fonts and shit in that shell, a blank page while it's all coming in, and all your content will stream in. Really, really powerful. You may be thinking, we did this in the 90s with server-side includes. That's true, but in the world, static and dynamic were separated into completely different technology worlds, and we didn't have incremental updates of static content. Consider the following e-commerce page: main head, my store, shopping cart, banner, suspense, recommendations, new products. With PPR enabled, this page generates a static shell based on your suspense boundaries. The fallback provided to React suspense is pre-rendered. Suspense fallbacks in the shell are then replaced with dynamic content, like reading cookies to determine the cart or showing a banner based on the user. That type of thing was not possible with older models. That would just have to be client-side code that ran after the static page was served. Under the hood of partial pre-rendering, when you build your application, Next.js will pre-render a static shell for each page of your application, leaving holes for the dynamic content. When a user visits a page, fast static shell is served from the end user's nearest edge region, allowing the user to start consuming the page immediately, and the client and the server to work in parallel. The client can start parsing scripts and style sheets, fonts, and all of that, while the server is doing its work to render the dynamic content. This is basically exactly what I just described. I think this is the really cool change here, is everything now can happen in parallel. Server doesn't block client, and client doesn't block server, and static doesn't block both. You can have a static piece the client gets immediately, so the client can start its work. The server gets kicked off at the same time, starts doing its work, and they all come together in the end. Really, really powerful. And because partial pre-rendering takes advantage of React's suspense boundary, you decide whether the boundary is static or dynamic. This is a really important piece that I feel like is getting missed. You choose where this breakdown happens by using suspense. The static shell retains the ability to be updated via ISR, and if you use features that require dynamic rendering, such as accessing cookies, Next will automatically switch the dynamic rendering up to the closest suspense boundary. This isn't just for app shells, as they said, such as in their product detail page, almost all the content is part of the static pre-render. So things like the nav bar, the image that's being rendered, the product, all of that still has to await. So it still blocks the first time. But since that content doesn't change per user or per request, it can be cached. And now you can manually invalidate it. Like let's say you rename the product. You can have a revalidate call that updates this URL so it regenerates. So the next person to hit it gets the correct page. But the goal here was to make it so you get that response as quickly as possible and don't have to worry about it from there. And another cool call out here is that this is open to all frameworks. Yes, Next supported it before Vercel did, but now that Vercel does, it's part of the build output API. So any framework can adopt this. And as Ryan Carniato said earlier, it would be a 2-line of code change to add this to Solid, supposedly. Would like to see that. And now he has a place to put it. Really, really cool. It's only on the Canary version now, and you have to turn it on as an experimental feature, which means it's going to break Turbo and a bunch of other stuff. I also call it's an experimental technology and it's not yet recommended for production use because that's going to stop me. Sorry, Vercel, I can't read. Regardless, this is a really cool major step. And as this stabilizes, I'm going to be really, really hyped and we're certainly going to be using it.
I also want to show one last example, which is my own blog, and talk about how partial pre-rendering is hopefully going to make this a lot easier for me. So on a blog post, the majority of this page is static. And in the top right, I have the view count. Now, the way
that I am totally covering right now. I'll unfull screen so you can see right there. There's a view count. Cool.
The way that I've been able to make this page entirely static and use ISR, so similar to the pages router model where you would define a revalidation time for the page, is inside of the page. So inside of this dynamic route here, I have a suspense boundary that's wrapping the views component. This views component is an async component that goes to my database, it fetches the views back, and then it renders this view counter. Now, this works, but unless over here on the right, unless I use this unstable cache function, this whole page would run dynamically. So not just this component, but this entire page would run dynamically. And like I said, there's just that one component in the top right. That's the only thing that requires me to run compute. So this works, but I want to make it easier and be able to have fresh data on every single request. I don't even need to use the stale while revalidate pattern here. So I just flipped over to a new branch where I've been experimenting with partial pre-rendering. And you'll notice not a lot really changes. So on the right, rather than wrapping this function with a cache and defining the revalidation time that I want, I can just go directly to the database. And then on the right, again, I already set up a suspense boundary, so I was already prepared for this change. I flipped on the feature flag. And then the only difference here is that I'm using no-store to opt in Next.js into dynamic rendering. Now, there's a bunch of different ways that you can opt into dynamic rendering. If you're using cookies, if you're reading headers, if you're setting no-store on a fetch directly. Since I'm going directly to the database using an ORM, I can just use this no-store function directly. And that's really all it takes. Now the rest.
So I like this a lot because I'm sure we've all heard and seen the confusion around caching in the new Next model. A lot of the time, the solution is to not cache if you don't have to. Let the CDN cache the page. And that's what's been done here. Since the majority of the page is static content, it's coming from a markdown file. None of that needs to change. And you shouldn't have to think in the context of the rest of the page when you're trying to add this one feature. Let the page be static. Let this one isolated component have dynamic behaviors and even manually call out to the compiler, hey, don't store the result of this. I want this to be dynamic every time.
The rest of this page is able to be partially pre-rendered. The static shell is able to be created. And then just the views are able to be streamed in when you hit the page. So that's all it takes. All right, so that was a fast run through of all things partial pre-rendering. Again, this is experimental. You can upgrade to Canary.
Y'all get the idea. I'm hyped on this. I'm so hyped on this that I'm starting to move things off of Edge because the main reason I used Edge was to make sure we had quick response times from our server without having to eat a Lambda cold start. But I don't care if it takes 2 seconds for the page content to come in if the user has something immediately. Because as I showed with the ping site, it still feels super, super fast. And when I go to a page, it shows up immediately. Even if the content is under a loading spinner, we have one loading spinner and everything flows in really nice. And that's a great experience, even if it takes a bit for that cold start to hit. So yeah, this solved a lot of the problems I had with Lambda and with cold starts. My old why I use Edge video is a little out of date now because the main reason I was using Edge is no longer as valid. That said, I still think it's a great video. And if you haven't already watched it, I'll pin it in the corner right there for you. And if you have, or you want to watch something else, YouTube thinks you like the video underneath it. Appreciate you all a ton. Thank you guys as always. Peace, nerds.